Ever wondered how electric vehicles manage their complex electrical systems? In this episode of Consumer Times, we dive deep into the sophisticated world of EV parameter measurement and control systems. From battery management to motor efficiency, discover the cutting-edge technology that makes modern electric vehicles safe, efficient, and reliable. Whether you're an EV owner, considering buying one, or just curious about automotive technology, this comprehensive guide breaks down the crucial parameters that keep electric vehicles running smoothly. Learn about voltage monitoring, thermal management, energy efficiency metrics, and the intelligent systems that protect your investment on wheels. Hello and welcome back to Consumer Times, where we help you understand the products and technologies that impact your daily life. I am your host Dr. Arun Kumar. Today, we're pulling back the curtain on one of the most sophisticated consumer technologies of our time, the electrical systems in electric vehicles and how they're measured and controlled. If you've ever driven an electric vehicle or even considered buying one, you've probably marveled at how smooth and responsive they feel. But what you don't see is the incredibly complex symphony of sensors, controllers, and management systems working together every millisecond to ensure your EV is safe, efficient, and performing at its best. Let's explore this fascinating world of measurement and control. Before we deep dive into the subject, understand the hidden technology behind electric vehicles is all about. Please give your valuable comments, like, share and subscribe to motivate us and understand what is the hidden technology behind electric vehicles. At the heart of every electric vehicle is the battery management system, or BMS. Think of it as the brain that constantly monitors and protects the most expensive component of your EV, the battery pack. The BMS measures dozens of critical parameters simultaneously. Voltage is continuously monitored at both the pack level and individual cell level. Modern EVs can have hundreds or even thousands of battery cells, and the BMS checks each one to ensure they're operating within safe voltage ranges, typically between 3 and 4 volts per cell. If any cell deviates from the acceptable range, the BMS takes immediate action to prevent damage or safety hazards. Current flow is another crucial parameter that's measured with extreme precision. The BMS tracks how much current is flowing into the battery during charging and out of the battery during driving. This isn't just about knowing your range, it's about protecting the battery from overcurrent conditions that could cause overheating or degradation. Advanced current sensors can detect variations as small as a few milliamps, allowing the system to optimize charging speeds and power delivery while maintaining battery health over hundreds of thousands of miles. Temperature monitoring is perhaps one of the most critical functions. Battery cells are incredibly sensitive to temperature, and their performance, safety, and longevity depend on staying within an optimal temperature window, usually between 20 and 35 degrees Celsius. The BMS uses multiple temperature sensors strategically placed throughout the battery pack to create a thermal map. If any area starts getting too hot or too cold, the thermal management system kicks in, circulating coolant or engaging heating elements to maintain ideal conditions. This is why your EV might take a few minutes to condition the battery before fast charging on a cold day. Beyond the battery, the motor control system is equally sophisticated. Electric motors in EVs are typically three-phase AC motors, and controlling them requires precise measurement and adjustment of electrical parameters hundreds of times per second. The motor controller constantly monitors phase currents, rotor position, and speed to deliver exactly the right amount of power at the right time. This is what gives electric vehicles their characteristic instant torque and smooth acceleration. The state of charge, or soak, is something every EV driver watches closely. It's your fuel gauge equivalent. But calculating soak accurately is surprisingly complex. The BMS uses multiple algorithms that combine voltage measurements, current integration over time, temperature compensation, and historical data about battery behavior. This is why your range estimate might fluctuate, The system is constantly refining its calculations based on real-time driving conditions, climate control usage, and even your driving style. Power electronics in EVs also require careful monitoring. The inverter, which converts DC power from the battery to AC power for the motor, generates significant heat and must operate within strict parameters. Voltage and current at both the DC and AC sides are continuously measured, along with switching frequency and semiconductor junction temperatures. Modern silicon carbide inverters are more efficient than older designs, but they still require precise control to maximize efficiency and prevent failure. Regenerative braking systems add another layer of complexity. When you lift off the accelerator or press the brake pedal, the motor becomes a generator, converting kinetic energy back into electrical energy to recharge the battery. The control system must measure vehicle speed, deceleration rate, battery state of charge, and battery temperature to determine how much regenerative braking can be safely applied. If the battery is fully charged or too cold, mechanical brakes must take over to avoid overcharging or damaging the battery. Safety parameters are monitored with redundancy built into every critical system. Insulation resistance is constantly checked to ensure there are no dangerous leakage currents that could create shock hazards. High voltage contactors are monitored to verify they open and close properly. Impact sensors can detect collisions and immediately disconnect the high voltage system to protect first responders and occupants. Every EV has multiple layers of protection, from fuses and circuit breakers to sophisticated software algorithms that can predict potential failures before they occur. Energy efficiency metrics give both the driver and the vehicle's control systems valuable feedback. Real-time energy consumption is measured in kilowatt-hours per 100 miles or kilometers, helping drivers understand how their behavior affects range. The vehicle's computer uses this data to optimize power delivery, climate control, and even route planning in vehicles with intelligent navigation systems. Communication between all these systems happens over high-speed networks, typically using the CAN bus protocol or newer automotive Ethernet standards. Data flows constantly between the battery management system, motor controller, thermal management system, vehicle stability control, and the driver information display. This integration allows for sophisticated features like one-pedal driving, where the vehicle automatically blends regenerative and friction braking for a seamless driving experience. So what does all this mean for you as a consumer? Understanding these systems helps you make informed decisions about EV ownership. When shopping for an electric vehicle, ask about the battery thermal management system. Active liquid cooling is generally superior to passive air cooling. Look for vehicles with sophisticated battery management that includes individual cell monitoring and balancing. Check if the manufacturer provides detailed energy consumption data and predictive range calculations. For current EV owners, understanding these parameters can help you maximize your vehicle's longevity. Avoid frequent charging to 100% unless necessary, as this stresses the battery management system. In extreme temperatures, precondition your battery while still plugged in. Pay attention to any warning messages about battery temperature or charging issues. These systems are designed to protect your investment. The measurement and control systems in electric vehicles represent some of the most advanced consumer technology available today. They work silently and invisibly, making thousands of decisions every second to keep you safe, maximize your range, and protect your battery for years to come. As EVs continue to evolve, these systems will only become more sophisticated, learning from millions of miles of driving data to deliver an even better experience. Thanks for watching Consumer Times. If you found this deep dive helpful, hit that like button and subscribe for more consumer technology insights. If you found this helpful, please like, subscribe, and share what topics should we cover next. Let us know in the comments below. What aspect of EV technology would you like us to explore next? Let us know in the comments below.